According to the National Electrical Code, specifically Section 215.2a, there's a requirement concerning the continuous load on a switchboard or switchgear assembly. This code section stipulates that the continuous load should not exceed 80% of the switchgear's rated current. In this situation of a UL 1558 listed switchgear rated at 4000 amps, this means the maximum allowable continuous load is 80% of 4000 amps. To calculate this, you multiply 4000 amps by 0.80, which equals 3200 amps. Therefore, in this scenario, the continuous load on the switchgear should not exceed 3200 amps to comply with NEC 215.2a. The NEC defines a continuous load as a load where the maximum current is expected to continue for 3 hours or more. It's crucial to accurately determine the continuous load on any electrical equipment to ensure it operates within its designed capacity and to prevent potential overheating, equipment failure, or fire hazards. When applying NEC 215.2a, it is important to consider any diversity or demand factors that may be applicable to the load. A diversity factor is the ratio or the sum of the individual maximum demands of the various loads to the maximum demand of the entire system. A demand factor is the ratio of the maximum demand of a system or part of a system to the total connected load of the system or part of the system under consideration. If the continuous load is supplied by several feeder breakers, each breaker must be sized to carry the calculated continuous load it serves. There are exceptions to the 80% continuous load limitation for overcurrent devices. One exception allows for overcurrent devices and assemblies, including switchgear, to be used at 100% of their rating if they are listed for 100% continuous operation. This means that the equipment has been tested and certified to carry its full rated current continuously without exceeding its temperature limits. However, it is important to note that even if the switchgear and breakers are listed for 100% continuous operation, a conductor supplying the equipment must still be sized to carry the calculated load, including any applicable demand factors. The conductors must also be protected by overcurrent devices sized to protect the conductors in accordance with NEC 240.4. When evaluating whether a switchgear assembly complies with NEC 215.2a, it is important to consider the following steps. Firstly, determine the rated current of the switchgear assembly. This information is typically found on the equipment's nameplate. Secondly, calculate 80% of the switchgear's rated current by multiplying the rated current by 0.80. This is the maximum allowable continuous load in the switchgear assembly. Thirdly, determine the actual continuous load on the switchgear assembly. This can be done by summing the continuous loads of all the circuits supplied by the switchgear. Finally, compare the actual continuous load to the maximum allowable continuous load. If the actual continuous load exceeds the maximum allowable continuous load, then there is a code violation. In the specific scenario where the switchgear is rated at 4000 amps and the continuous load is 3900 amps, the 80% limitation of NEC 215.2a is exceeded unless the switchgear assembly and its overcurrent protective devices are specifically listed for 100% continuous operation. If the equipment is not listed for 100% continuous operation, then the continuous load must be reduced to 3200 amps or less to comply with the code. The NEC provides detailed requirements for the installation and sizing of electrical equipment. It is important to consult the NEC and other applicable standards to ensure that all electrical installations are safe and compliant. In addition to the NEC, other standards may also apply to switchgear assemblies such as UL 1558, which is the standard for switchgear assemblies. UL 1558 provides requirements for the design, construction, and testing of switchgear assemblies to ensure that they are safe and reliable. Compliance with UL 1558 is often required by local building codes and regulations. When selecting switchgear for a particular application, it is important to consider the following factors. Firstly, the rated current of the switchgear. Secondly, the available fault current at the installation location. Thirdly, the environmental conditions at the installation location. Fourthly, the specific requirements of the application. The rated current of the switchgear must be sufficient to carry the maximum load that will be connected to it. The available fault current at the installation location must be less than the switchgear's short-circuit current rating. The environmental conditions at the installation location, such as temperature and humidity, must be within the switchgear's operating limits. The specific requirements of the application, such as the need for redundancy or remote monitoring, must be considered when selecting switchgear. Switchgear is a critical component of electrical power distribution systems. It is used to control, protect, and isolate electrical equipment. Proper selection, installation, and maintenance of switchgear are essential for ensuring the safe and reliable operation of electrical systems. Failure to comply with the NEC and other applicable standards can result in equipment failure, fire hazards, and other safety risks. Therefore, it is important to consult with qualified electrical professionals to ensure that all electrical installations are code compliant. Now let's delve into some common misconceptions about switchgear and continuous loads. One common misconception is that if the individual breakers within the switchgear are rated for 100% continuous duty, then the entire switchgear assembly can handle a 100% continuous load. This is not necessarily true. The switchgear assembly itself must be listed and labeled for 100% continuous operation. The listing ensures that the entire assembly, including the busbars, connections, and other components, can withstand the heat generated by a continuous load without exceeding temperature limits. Another misconception is that demand factors can always be applied to reduce the calculated continuous load. While demand factors can be applied in certain situations, they must be based on documented data and engineering analysis. Demand factors should not be used to arbitrarily reduce the calculated load below the actual expected continuous load. Over-reliance on demand factors can lead to undersized equipment and potential overloading. A further misconception is that occasional overloads are acceptable as long as they are infrequent and short in duration. However, even short-duration overloads can damage equipment and reduce its lifespan. Continuous operation near or above the rated capacity can accelerate wear and tear on components, leading to premature failure. It is essential to design electrical systems with sufficient capacity to handle the expected continuous load, with some margin for future growth. The NEC provides specific guidelines for calculating loads and sizing equipment to ensure safe and reliable operation. Ignoring these guidelines can have serious consequences. Let's consider the implications of a code violation related to switchgear and continuous loads. A code violation can result in several potential problems. Firstly, it can create a safety hazard. Overloaded switchgear can overheat, leading to insulation breakdown, arcing, and potentially fire. Secondly, a code violation can result in fines and penalties from regulatory authorities. Electrical inspectors have the authority to issue citations and require corrective action for code violations. Thirdly, a code violation can void insurance coverage. Insurance companies may deny claims if a fire or other incident is caused by a code violation. Fourthly, a code violation can damage equipment and reduce its lifespan. Overloading switchgear can accelerate wear and tear on components, leading to premature failure and costly repairs. To avoid code violations related to switchgear and continuous loads, it is important to firstly, accurately calculate the continuous load on the switchgear. Secondly, select switchgear with a rated current that is sufficient to handle the continuous load. Thirdly, ensure that the switchgear is listed and labeled for its intended application. Fourthly, install the switchgear in accordance with the manufacturer's instructions and the NEC. Fifthly, regularly inspect and maintain the switchgear to ensure that it is operating properly. In addition to these general guidelines, there are some specific considerations for different types of switchgear. For example, metal-clad switchgear typically has a higher short-circuit current rating than metal-enclosed switchgear. Gas-insulated switchgear is often used in applications where space is limited or where environmental conditions are harsh. Solid-state switchgear is becoming increasingly popular due to its compact size, high reliability, and advanced features. The selection of the appropriate type of switchgear depends on the specific requirements of the application. It is important to consult with qualified electrical professionals to determine the best type of switchgear for a particular installation. Also, switchgear maintenance is an often overlooked aspect of electrical safety. Regular maintenance is essential for ensuring that switchgear operates reliably and safely. A typical maintenance program for switchgear includes firstly, visual inspection, secondly, cleaning, thirdly, lubrication, fourthly, testing. Visual inspection involves checking for signs of damage such as cracked insulators, loose connections, and corrosion. Cleaning involves removing dust, dirt, and other contaminants from the switchgear components. Lubrication involves applying lubricant to moving parts to reduce friction and wear. Testing involves performing electrical tests to verify the switchgear's performance, such as insulation resistance tests, contact resistance tests, and timing tests. The frequency of maintenance depends on the type of switchgear, the environmental conditions, and the operating conditions. However, as a general rule, switchgear should be inspected and maintained at least annually. More frequent maintenance may be required for switchgear that is operating in harsh environments or that is subjected to heavy loads. Proper maintenance can extend the lifespan of switchgear and prevent costly failures. In summary, understanding the NEC requirements for continuous loads on switchgear is crucial for electrical safety and code compliance. By accurately calculating loads, selecting appropriate equipment, and performing regular maintenance, you can ensure that your electrical systems operate reliably and safely. Failing to comply with these requirements can result in safety hazards, code violations, and equipment failures. Always consult with qualified electrical professionals to ensure that your electrical installations are code compliant and safe. Remember that the 80% rule in NEC 215.2 is a fundamental principle for preventing overheating and ensuring the longevity of electrical equipment. While exceptions exist for equipment listed for 100% continuous operation, these exceptions require careful verification and documentation. When in doubt, it is always best to err on the side of caution and design electrical systems with sufficient capacity to handle the expected continuous load. By following these guidelines, you can help to create a safer and more reliable electrical environment.